Hey everyone, in today's video we're going to be talking about the top view of a binary tree. So what does the top view of a binary tree basically means? It basically means that if I look at the tree from the top over here somewhere, how would the tree look like? Right. So if I look at the tree from the top, I can basically, if and on a first glance, you could all obviously just tell me that what I can just see from the top is like a one, right? But that's just not it, right? What you can see from this, let's say, just taking this example of this tree, you can see that all the extremes of the tree could be visible, right? Because if I look at the tree, I can see this portion, this portion, this portion, this, and this, right? So all the extremes of the tree are visible from the top. Right. But I don't think this would give you a clear depiction of what the question is. Now, let me just explain you how you can visualize the question much more better. Right. If it tells you to find the top view of a binary tree, what you can do is start making columns on the tree. Right. So what if I make a column over here? Right. This is one of my columns. This is my second column. This is my third column. This is my fourth column. This is my fifth column. Right. And now I start marking these columns. Let's say the column at 1 over here is going to be the column 0. Right? It has a value of 0. Right. Basically, I'm just trying to depict it on a 2D plane. Right. When I try to depict it on a 2D plane, let's not take, rows in this case scenario. Let's just take uh, let's just take the columns, right? The vertical axis, not the horizontal one. Right. If I take the vertical axis and let's say I mark this one with a 0, right? It's on column 0. Right. So what does it basically mean? That if I go to the left of the tree, right, this 2 will have a column of -1, because everything to the left of a number line would basically be uh, to the left of 0 is going to be negative. Everything to the left right of 0 is going to be positive, right? As you know from the number line concept in maths. So like if I have a number line like this, I have a 0 over here, I have a 1, I have a 2, I have a 3. This would be my -1, this would be my -2, -3, right? So this is what the number line is. Right. So if I have 1 on my column 0, right, and 2 is on the left of 1, we can just think of this 2 be on the column -1 over here, right? And this 3 is going to be on the column +1, right? Now, if I go to 2, I can see that this 5 is on the right of 2, which basically means that I can just maybe add a 1 to it and just imagine this 5 to be on the same column as this column 0, right? So you can have like this 5 can also be in the column 0 over here, right? Now, if I go to this 4 is going to be in a column of -2 because it's on the left of this 2. When I go to 3, I can see that the 6 is on maybe the 0th column again because it's on the left of this one, right? And this 7 is on the right of it, which can be column of +2, right? And this is just an imaginary depiction. Okay. I'm just incrementing it by 1 and subtracting it by 1 in case of left and right. Okay. So we can imagine it like this, right? So that is why I made these columns like this, just for your explanation, right? There's one column in -2, at one at -1, one at 0, one at 1 over here, and one at +2 over here, right? Now, when ask you what the top view of a binary tree is, right? The top view is of the binary tree is basically all the nodes at the surface level. When I say the surface level, it means all of these nodes, right, that I can see from the top, right? And what I mean by what I mean by when I get secant from the top, right, that these two nodes over here, 5 and 6, right, are not visible from the top because they're getting, they're getting hidden from this node 1 over here from the top, right? Because it's on the very topmost node. It's the most top node over here, right? And it's kind of hiding these two nodes below it because they're on the same column level, right? That's what it basically means when I ask you the top view of a binary tree. It means that tell me all the topmost nodes of a particular column, right? So over here, 0 is the topmost node, 1 is the topmost node of the 0th column, right? And 5 and 6 are at the same level. They both are in the same row level, you could say. Let's say they both are in the same row level 2 over here. If I think of this as a row, this is a row 2, this is a row 1, and this is a row 0, right? They both are in the same row, but 0 is at the top of this, at the most top row over here, right? That's why these two nodes are getting hidden from the most topmost row, right? That is what you need to basically identify, right? So what does the top view of a binary tree means is that you need to find the topmost column of a particular row, It basically means that you need to find the topmost column, topmost node in a particular column. When I say topmost, I literally mean, I literally mean the topmost node over here. Literally, I mean the topmost node, right? That these two nodes are below this one, right? That's why it's not going to be the topmost. Now, to give you another example, let's say we have a one, two, three, four, right? And we have a five over here. And let's say we have a six, we have a seven, we have a eight, right? And we have a nine over here. Okay. Now, if you want to imagine, let's say this is the column zero, this is minus one, this is plus one, this is plus two, this is plus three, this is plus one, this is going to be minus two, minus one, minus three. Right. Now, the topmost nodes of each column are going to be a part of the top view of the binary tree. So, what are the topmost nodes? Over here, 5 and 9 are the only two nodes that are at the same level as another node. Let's say at the same column level, like 5 is at the same column level as 2, and 9 is the same column level as 6. But because 2 and 6 are at the topmost level, right, at the topmost row, you could say, of this particular column, so you need to print them in the top view. So if I try to print the top view of this tree, it will be 4, 3, 2, 1, 6, 7, and 8. So this is what the top view of this binary tree would look like. This is going to be 4 of minus 3, 3 of minus 2, 2 of minus 1, 1 of 0, 6, 1 of 6, plus 1 of 6, plus 2 of 7, and plus 3 of 8. Right? 9 is on the plus 1 side, but 6 is on the topmost node. So basically, what you need to identify is for each column level, find the node which is at the topmost row. Right? Basically, when I say the topmost row is the smallest row, and the smallest row over here is going to be this one. But this is basically a row zero. This is row one. This is row two. This is row three. Right? So you need to find all the nodes, right, at the topmost of each column level that have the smallest row number, basically. Okay. So if I go back to the previous example, or I just make a new one over here, right? So if I go back to the previous example, one, two, three, four, five, six, and seven, and I make all the rows and columns. Okay, row one, two, three, four, five. And that was my column. Sorry, this is my rows. Right. If I make them all like this is going to be my row zero, row one, row two. Right, and these are my columns. This is my column one. So this is my column zero. Right. This is my column plus one. This is my column. Oh, sorry. This is my column minus one. Okay. Yeah, this is my column minus one. This is my column plus one. This is my column minus two. This is zero. This is zero, and this is plus two. Right. So the top view of the binary tree is basically uh, for each column level, find the node with the smallest row level, right? So this is what basically the top view of a binary tree is. So if I so for each column level, so let's say my column level is zero, right? For my column level zero, which is the node with the smallest row level, it's zero again. So I'm going to print out zero over here. Sorry, I'm going to print out one over here. Okay. So one will be a part of the top view of binary tree. So if I go to so if I go to minus one, column level minus one. If I go to column level minus one, which is the node with the smallest row level, it's going to be two. So two is going to get printed. For plus one, it's going to be node three, and with the smallest row level, it's going to be three. For column minus two, it's going to be four with the smallest row level, right? So four is going to get printed, and for plus two, it's going to be seven. So seven is going to get printed. Now, if I want to write, okay, let me just rub all of this. Take a bigger eraser, right? So if I want to write the top view of this binary tree, we need to write it from left to right, right? So the leftmost is -2. So we write it from there. It's going to be 4, 2, 1, 3, and 7. So this is going to be the top view of a binary tree, right? So I hope the question is clear to you guys. What you need to do in the question and how to identify the top view of a binary tree. So you just need to find, just to summarize, you need to find for each column level, you need to identify the node with the smallest row level. Okay. I hope if you can't even imagine what I mean, it's pretty clear when you look at a tree what are going to be the nodes that you need to put in. But if you can't imagine it, you can just remember this, that you need to find for each column level the node with the smallest row level. All right. So this is basically what it is. So all right, now how are we going to solve this problem? Right. So we have 1, 2, 3, 4, 5, 6, and 7. Right. Now how are we going to solve this problem? Okay. So what are we going to do is we're going to basically just perform a BFS traversal in this case. Okay, so what a BFS traversal is basically a level order traversal. So in a BFS level order traversal, what we do is firstly we just maintain a queue, right? So what we'll do is we'll maintain a queue over here, right? At the initial step, we'll have our node one over here, right? And we'll just stick in a row, which is basically a root node. So let's say we stick in one, and we stick in with its column level, which is going to be zero. Okay, let me just rub this. Okay, let me just make it again. Okay, so we're going to stick in our node. This is our node, which is 1 with its column level, right? It's going to be at a column 0. So let me just make the columns for you one more time. So this is at column 0. This is -1. This is +1. Sorry, -2. Okay, let me make it with a different color so that it's visible properly. So yeah, let me just make it with this. So this is row 0. This is row -1. So row -2. This is 0, 0, +1, and +2. Okay, right? So what we're going to do is initially we're going to create a queue over here, right? And we're going to store the very first node value and its node value, which is 1, with its column value, all right? And also what we'll do is we'll maintain like a dictionary, right? Or a hash map, you could say, right? Which is basically going to store all the answers for you, right? We'll create a hash map and store just so that we can, store all the nodes with the topmost row level. Okay, for each column you can store all the nodes with the topmost row level over here, right? So now what we'll do is we'll check while queue is not empty, right? While queue is not empty, what we'll do is we'll pop out the node from the queue, right? We'll pop it out, queue dot pop of 0, right? So this pops out our very first node, all right? In this case, right now, our queue is empty and we have it popped out, right? So node over here, let me just write it with a different color. So node over here is storing a 1 and a 0, right? Now what we'll do with this 1 and 0 is, okay, what we'll do with this 1 and 0 is firstly, we'll store one of the values with column, which is going to be node of 1. And we can maybe, make like a data value or something like that, and store the value of node of 0 of dot data like this. You can store the data value of it, and this can basically cur could just store the node, right? Node of 0, right? All right. Now what we'll do with this is, since we have a data broken down into chunks over here now, right? We broke this node down into a column, uh, just to separate out the values. This can be a column, this is going to be a data, and this is going to be a current node, right? Now what we'll do is we remove the value from the queue, right? Now what we'll do is we'll not perform like a general level or traversal. We'll not keep like a levels array or something where we store the two levels and then we go to the third level. We won't do that. What we'll do is we'll just check. Firstly what we'll do is we'll just check if this node is present in our hash map or not, right? So we'll firstly what we'll do we'll just take our node if if data. So data is going to store the value of this one. This one is basically the whole node, right? And we won't store the value of it. We just check if data not an answer, right? And we'll store this value answer the data. All right. Oh, sorry. We won't store the data. I'm sorry. We'll store the column over here, not the data. Right. What we'll do is we'll check if the column was previously present in it or not. So if call an answer and not an answer, if call not an answer, right? If column was not present in answer, what we'll do is we'll store answer of call equal to data, right? So we're creating a hash map over here on the side. So this is our answer, right? So in our very first visit, we created a hash map. We have a column equal to 0, right? Because we popped this out. Let me just write this also in a different color. Right now, this is equal to 0. Our data is equal to 1, and our current is equal to the node 1, right? The node 1. All right. So this is what our current status is. Now, since we checked this, we're going to check if answer is present in call or not. And if it's not present, what we'll do is we'll just store this value, right? For our column 0, we'll store the data 1. Right. Now, what are we going to do? What we do is we check if it's not present, right? And if it's not present, we store in the data. Cool. Also, now after this is done, what we do is we check if it has a left value or a right value or not. Right. We'll check. Let me just change the color. Yeah. If cur, which is the node now, dot left. If cur dot left is present, we'll store it in the queue like this. Queue dot append. And how we'll store it? What we're going to store over here is our current this cur dot left, comma call -1. Right. Since we're going to the left, as I explained you in the number line, since we go to the left, right? Since we go to the left, we're going to store the value of call -1 in the node. So in this case, this is going to get removed. This gets popped out, right? So let me just remove this. Let's not remove this. We'll just keep this. But this gets popped out in a very first sequence, and when it popped out, I put something like, and if it has a left, this case it does have a left. We'll store the node 2. This is going to be the node 2, and we're going to store it with its column -1. And why -1? Because in the number line, as I told you, as you go to the left, we store the value. I'm just going to store the value with a negative minus thing to 1, because when I'm going to the left, right? When I go from 2 to 4, I'll store it with -1, which is going to be -2. Cool. That's why I'm storing it with -1 over here. That's why I'm doing a call -1 over here, right? It's a cur dot left. Let me just write it on the same line. So it's going to be, let's write the whole thing on a streamline. So it's going to be something like q dot append like this. It's going to be a cur dot left, comma call -1, right? So this is going to what's going to get appended. Now, if cur dot right is present, right, we'll also store that. We'll do a q dot append a cur dot right, comma call +1, right? So in this case, at the very first, after going inside the very first node, what we're doing is we're storing 2, the node 2 and -1, and we're also storing 3 and +1, right? We're storing these two values as we go down. Cool. Now, what's going to happen? So basically, the main code is basically just this much. Now, I'll do a dry run to show you what's going to happen after, and we'll go forward from the code after that. Let's just dry run the whole code up till here and see what's going to happen. Right. So in the very first scenario, as you saw, when we take the node 1, after taking the node 1, when we go to the most bottommost line of the code, we get these two values popped in. Now, since the code is done, what we'll do is we'll check again. While queue, since the queue is not empty, what we're going to do is pop the node. We'll pop the very first node because this is a queue. We pop the very first node, so this is going to be Okay, so let me just write it like this properly. So this is, it's removed, this gets removed, this is okay. Right. So this is going to be our -1. This is data is going to be 2, and this is going to be node 2. Right. Now, what we do is we check if call not an answer. So is the column -1 in our hash map right now? So no, up till now we only have a 0 in our hash map. So what we're going to do is we're going to store -1 in our hash map like this with the data which is 2. Right. So the data 2 gets appended, gets added to the hash map. Right. Now what we're going to do is we're going to check if cur dot left, right? If cur dot left, does it have a left? Yes, 2 has a left, which is 4. So what we'll do is we're going to append cur dot left and call -1. So since we're appending it, what we'll do is we can just write, I'll just write down over here after this 3. Okay, let me just change the color as well. Okay. Yeah. So what we're going to write down over here is we'll have a cur dot left, which is, what is it? It's a 4. Okay. So it's a 4, and it's going to be a call of -1. So the current call is -1. So -1 -1 is going to be a -2 that gets stored. Okay. The next line is if cur dot write, q dot append cur dot write and call +1. Right. So cur does have a write. So it's going to be a 5, right? And 5 and 0 because it's going to be a call +1. So -1 +1 is going to be a 0. So this gets appended. Right. Now this line is completed. Now we go back to the queue. We see if the queue is empty. So the queue is not empty. What we'll do is we'll pop out the next element, which is 3 and +1, right? So if it's 3 and +1, let's erase this over here. Let me just erase this, this. Okay. So it's going to be a 3 and +1, which gets popped. So this is going to be a +1. This is going to be 3, and this is going to be 3. Right. Now what we do is, okay, right, we're just going to check if call not an answer. So is +1 in our answer hash map? So no, it's not there. So what we'll do is make a +1 and we'll append 3 to the hash map. Right. We'll just append that to the hash map, and we'll check if cur dot left present or cur dot right present. So yeah, we'll see if 6, it has a left, 6 is present. So we'll append 6 over here. So we'll append 6 with a -1, which is going to be a 0. So +1 -1 is going to be a 0. And cur dot right, yeah, it does have a cur dot right. So we're going to append 7 and +2. So it's going to be a 1 +1 is going to be a 2. Right. Now we go back to the top and we're going to check uh, if queue is empty or not. So the queue is not empty, and we'll pop this element out, 4 and -2. So when 4 and -2 gets popped out, right? 4 and -2 gets popped out. Let me just write this here. This is -2. This is 4, and our node is 4. Right. What we'll do now, we'll check if -2 is present in the answer column, answer hash map or not. So -2 is also not present. So what we'll do is we'll add -2 over here with our data, which is 4 over here. Right. So this also gets appended. Now, do we check if it has a left and if it has a right? So in all in the case over here, it doesn't have a left, so we won't append anything to the queue. It doesn't have a right, so we won't append anything, and we're done. Right. Since we're done, we just go to the next element and pop it out, which is 5 and 0. Right. After popping out this element, let me just use my eraser here again. Okay. Okay. Yeah. So we popped out 5 and 0. So this is gonna be our column 0. This is gonna be our node 5. This is gonna be a node 5. Right. Now what we're doing is we're going to check. We'll check if answer is present in column, if column is present in answer or not. So our column right now is 0, right? So is 0 present? So 0 is present. So we won't add anything. Basically, we won't add 5 to the list over here, and we'll just go forward and we'll check if it has a left and right. So it doesn't have a left and right. So we'll just go to the next element. Right. In the next element, we have a 6 over here. Right. So when we have a 6, it has the same column. This is going to be a 6, and this is going to be a 6. Now we're going to check if column is present in answer. So yes, column 0 is present in answer. So we won't do anything. We will check for left and right. It doesn't have anything. So we'll go to the last element, which is 7 and +2. When we go to 7 and +2, this is going to be +2. This is going to be 7. This is going to be 7. Right. Now, when we have this, we'll check if answer is present, column is present in answer. So no, plus two is not present. So we'll add plus two over here like this, right? And we'll check for left and right. So it doesn't have a left and right. So we just come out from the array. So we just come out from the loop over here, the while loop over here, because the queue is also empty now since we popped out all the elements from the queue, right? Since all the elements are popped out, now after finishing this queue, after finishing this loop, what we get is we get an answer hash map, right? Now if you look closely to the answer hash map over here, you'll see that this is basically the answer which you got, right? You have one, you have two, you have three, we have four, we have seven, right? You've wanted the same things: one, two, four, 3, and 7, right? 5 and 6 are not added because they're not part of it, right? So the main essence of the code is basically just this one line of code, you know, where we just traverse through the where we just add elements to the queue and we pop each element out, right? And as we pop each element out, the very first elements, the topmost elements obviously will get added to the will get added first inside to the queue, right? Because if we start with the root node, it's gonna go to the most topmost left node and the most topmost right node, right? What I mean by that is 2 and 3 are the topmost left and right nodes over here, because 1 is our topmost node, right? This is the most top node we have, right? And 2 and 3 are our topmost left node, and this is our topmost right node, right? So basically what I want to tell you guys is that we start from the top, and as we go down, right, all the nodes which are at the top, which have the smaller row levels, so this is row level 0, this is row level 1, this is row level 2, all the nodes which have a smaller row level are going to get added to the added to the queue first, right? So since all the nodes that get added to the are going to get added to the queue first, right, we can just maintain like a hash map and check what column level was called first, right? So obviously first I'm going to append this row level, then I'm going to append this row level, then this row level, all the nodes from this row level are going to get appended, right? So what I just need to check is for each row level, what I'm just basically checking is, as when I appended this node, it's basically I'm appending all the nodes at row 0, right? Now when I append the second row, second set of elements, which is 2 1 and 2 minus 1 3 plus 1, so basically these two guys over here, I'm basically appending all the nodes from row 2, right? That's what I'm doing basically, and this is all the nodes from row 3 which are getting appended, right? So what I'm just going to check, what I'm trying to do in this whole code is I'm just checking for each all the nodes in each or the topmost row level are getting added first. That's what I know from this code. Now since I know that all the nodes from the topmost row level from the lowest row levels are going to get added first, I just need to check which, for each column, which has the lowest which node has the lowest row level, and it's going to be the node which gets appended first, right? If you think about it logically, so 1 and 0 gets added, right? So 0 is getting added first, which means that this is for column 0, this is for column 0, right? But if you think about it, for row, this is also the smallest row level because it's getting appended very first inside the queue, right? So since it's getting appended inside the queue in the very start, so we can just say that this one, if I just if I try to find this row, if I try to find the node which is at the most topmost level of the node over here, so like if I try to find the node which is the most node over here, so 1 is at the topmost node over here, I can say that this node will be visible from the top view, right? Similarly, when I go to 2 and when I go to 3, I can say that these two nodes are visible from the top for these column values, right? And when I go to 5 and 6, because 1 was already called, right? Because 1 was already called, this means that this was at the lowest row level, right? Because it was appended first, which basically means that it was at the lowest row level. It was at a smaller row level compared to these two, right? That's why it was called first, and that's why these two won't get appended, and this column level does get added, right? So this is basically what the intuition is, guys. I really hope you understood what I tried to explain to you guys. So from that, what we got was an answer hash map, right? So since we got an answer hash map, now what we just need to do is we just need to loop through the basically what we just need to do is we just need to loop through this, and we need to find all the key values and try to sort it out. And after looping through this and finding all the sorted key values, we can just loop through all the sorted key values and print out all the values one by one. So basically what I'll just do is I'll try to make just create something like a for loop for key in answer.keys, right? And I'll store all the values in a key array, you could say. So key dot append keys, right? So all the values in the key would be appended. So I'll get something like this: key of 0, -1, +1, -2, +2. Right. Now what I'll do with these values is I'll sort them out. So I write a key dot sort. So if I sort them out, what I'll get is basically an array like this: key of -2, -1, 0, +1, and +2. And lastly, what I'll do is I'll just loop through this key list for I in key, right? And this is going to be my answer, let's say, or result, because the answer is already used. I'll just create an array called result over here, and I'll just loop through the key, and I'll append the value that is an answer for each key value, for each I value. So res dot append answer of I, right? So it appends all the value for answer of I. So answer of -2 is going to be 7. Sorry, answer of -2 is going to be 4. So basically, the complete answer is going to be -4, then 2, then 1, then 3, then 7, right? Because it's -2, -1, 0, +1, +2. So the final answer is 4 is 4 -2, 1, 4 -2, 1, 4 -2, sorry, 4, 2, 1, 3, and 7. 1, 3, and 7. So this is basically the final top view of a binary tree, right? So this is what the whole code is, guys. I hope you understood how what I tried to explain to you. So let me just show you what the code looks like. Okay, so this is how the code is, guys. As I explained to you, I just created a queue. I stored the topmost node, which is the root with its column value. I created a dictionary, right? And I'm just doing whatever I told you. Right? I create a value, I create a column, I create value R to store the node of the current node, right? Then I'm just checking if it's present. Then we check for the left and right, right? If everything is there, then we check for keys. Then I just loop through the keys, all of them. I sort them out, and finally I just take each element inside the key and append it to the answer array and just return the answer. So yeah, guys, this is all the whole code. Let me just show you after submitting it. Yeah, it's submitted. So yeah, guys, this is for the video. So the time complexity of the code is going to be O of n log n. It's n log n because we're sorting them out over here, and the height of the tree is going to be O of n because we're using a queue, and we're also using a dictionary, obviously. So we're using a queue and dictionary, and it's going to be O of n because the maximum limit of it could be for the maximum the for the maximum to be the maximum height of the tree, right? So this is what the question is, guys. So thanks for watching. If you like the video, do like, share, and subscribe. Do let me in the comments what I can do better to teach you the concepts. If you didn't understand anything, because I do feel like I fumbled a lot in this question and the bit in this between. So if you didn't understand anything, do let me know how I can explain it to you guys better. And also, just want to let you know, guys, there's like a small 10% discount coupon code from Geeks for Geeks. So if you want to take the course over here, so Geeks for Geeks, and course, yeah. So yeah, guys. So if you guys want to check out this course, I think it's the self-paced data structures and algorithms course. Uh, I have a 10% discount coupon on for the Python programming language. So you can check this out. I'll post the coupon code on the description below. If you like the, and also guys, yeah, if you like the video, do like, share, and subscribe. Do let me know in the comments, as I told you, what I can do better. And until next time, guys, thanks for watching.